The Python language sheds its skin every 17 months and comes out as an improved creature. It can be tough to keep up. That's why we're here, to discuss the major new features, improvements, and deprecations so that you can stay current with the Python language. My name is Claire Byrne, and I'm a data engineer specialising in Python. I have a master's degree in cybersecurity from Queen's University Belfast, and I currently work as a security data engineer at Elastic, the company behind Elasticsearch and the Elk Stack. I've been volunteering with the global organisation Women Who Code for over 7 years now, where I teach and mentor women in their technical careers all over the world. I also founded the annual Women Tech Makers Belfast conference. I'm super passionate about giving back to the tech scene. Finally, I'll talk you through how to port to Python 3.10 from an older version, no matter what operating system you're on. This course assumes a level of familiarity with the Python language and with software engineering in general. I'm super excited to go on this journey with you, so let's dive right in. Hey everyone! In this video, we'll go over some of the jargon used in a version release of Python. Feel free to skip this video if any of the following applies to you. 1. You're familiar with PEP already. 2. You've watched this same video in my First Look Python 3.9 course, or 3. If you're a seasoned developer and you already know about the Python release process and its terminology. So first of all, you're going to be seeing the acronym PEP a lot within these videos. PEP stands for Python Enhancement Proposal. A PEP is a technical design doc for the Python community, which describes a new feature for the language itself, its processes, or its environment. Any PEP for a new language feature will provide a technical spec for the feature and the reason why it's been included in this release. So just a few top terminology tips now. Don't confuse PEP with PIP, which is the standard package manager for Python. According to the original author, PIP stands for Pip Installs Packages. As someone who works in tech, I can never get enough of recursive acronyms. PIP should also not be confused with PyPy, which is the Python package index. This is the official third-party software repository for Python, where PIP gets its packages from by default. These are all pretty similar terms that confused me when I was starting out, so hopefully this video helps a little. But I digress. Back to PEP. The main audience for PEPs are the core developers of Python, and developers who code in Python. I found that they're absolutely invaluable from a day-to-day Python dev standpoint too. It's really fun to be able to play around with the new language features when an update happens. There are 3 kinds of PEP. A standards track PEP describes a new feature or implementation for Python. It may also describe a standard that will be supported outside the standard library, but will be added in a future release. An informational PEP describes a Python design issue, or provides general guidelines or information to the Python community. It doesn't propose a new feature, and these PEPs don't necessarily represent a Python community consensus. A process PEP describes a process surrounding Python and applies to areas other than the codebase itself. They usually do require community consensus, and users must follow them as best they can. Examples include procedures, guidelines, changes to the decision-making process, and changes to the tools or environment used in Python development. So what usually happens during a Python release then? Well, according to PEP 6.02, each release for Python 3 will be developed for around 17 months. With the official development for the Python 3.10 release having begun in May 2020, this release will happen officially on the 4th of October 2021. The release schedule for Python 3.10 has its own PEP, PEP 6.19, which details the release schedule, the lifespan, and the major features that will be included. Subsequent bug fixes will happen monthly for around 12 months after this, and following that, it's expected that security updates will be released until approximately October 2026. So there you have it. That covers the very basics of Python software releases. Join me in the next video for a more in-depth dive into what's new in Python 3.10. Hi everyone! I hope you're just as excited about the release of Python 3.10 as I am. There have been some fantastic new features added in this release. Especially notable is the addition of pattern matching to the Python language. I'll be talking more in depth about pattern matching and type hinting in another video, so stay tuned. The new features in Python 3.10 can be broken down into a few distinct categories. New syntax features include pattern matching and the fact we can now use parentheses to group multiple with statements without having to use backslashes. Exciting times! The next broad category of new features is typing enhancements. I can almost hear the TypeScript developers and set theorists in the audience cheering, as this release of Python introduces the concept of union types, written as x_y. Another nice type addition is the inclusion of explicit type aliases, which are user-specified types which may be as complex as any type hint. Type hints are used to specify the argument types and return types of functions. And now user-defined types can be used this way, with a simple variable annotation. I know this feature will make a lot of my colleagues very happy and eliminate many of the wiggly red lines in our IDEs. Another notable feature is the addition of strict line numbers for debugging and other tools, as detailed in PEP 626. This guarantees that when tracing is turned on, line tracing events are generated for all lines of code that are executed. In terms of standard library feature additions, there's been a sigh of relief from me involving the zip function. This function now has an optional strict keyword that will ensure the arguments to this function are the same length. Previously, zip would just accept iterables of different lengths and fail silently if the lengths were different, so this is a great addition. And finally, there have been a few notable deprecations and removals in Python 3.10. CPython's standard library will now only support OpenSSL 1.1.1 LTS or newer, with all older versions being dropped. The distutils module, which is a collection of utilities for packaging and distributing Python packages, is now deprecated completely, in favour of using the setup tools or packaging modules. Some cleanup of deprecated Unicode APIs is happening, or is planned to happen, with the removal of WString and the PyUnicode encoder APIs by Python 3.12. Additionally, a new encoding warning, has been added for when the encoding of a file is not specified when using the open function. So those were the highlights from a bird's eye view. There's a lot to dive into though, so join me in the next video for a discussion on the much anticipated new features that I can't wait to use. Everyone knows that reading release notes isn't the most exciting thing in the world. Have you ever wished that someone would just read them for you and tell you the best bits? Well, you're in luck. While we're here together now, I'll give you an overview of the new PEP features that are included in Python 3.10. The first feature I'm going to dive into is parenthesized context managers. Sound confusing? You've all definitely used a context manager within your file handling code before. Context managers use the Python with statement, which lets you allocate and release resources precisely when you want to. This is especially useful when we have two related operations, like opening and closing a file we'd like to execute as a pair, with a block of code in between. The code shown on screen opens a file, writes some data to it, and then closes it automatically when the context is ended. This means we don't have to panic when we accidentally forget to close a file. It's handled for us. And that brings us to our new feature then. Brackets to capture multiple lines when defining context managers are now supported. This allows formatting a long collection of context managers across multiple lines, much like you can do with import statements. For instance, all these examples on screen are now valid, and more. Neat! The next new feature I'm going to talk about is better error messages. We've all been there, staring incredulously at our computer screens as Python tells us unhelpfully that there's been a syntax error, or an unexpected end-of-file error in our copy-pasted JSON. Where are the unclosed brackets? Mysteries abound. But never fear, Python 3.10 is here. With its new improved error messages, it will actually tell you the location of the unclosed bracket or quote mark, saving us developers a lot of time and substantially reducing traffic to online JSON linters. Another improvement in error handling is that Python will now highlight the full error range of the syntax error itself, instead of just vaguely where the problem is detected. Another great new feature is the huge amount of new specialized messages for syntax error exceptions which have been included in Python 3.10. You can see them here on screen. I could go on and on about the enhancements that have been made to error handling in Python 3.10. Attribute errors will now offer suggestions of similar attribute names in case you spelt something wrong. Indentation errors now have more context regarding what kind of block was expecting an indentation, as well as the location of the error. Name errors will now offer suggestions of similar variable names in the function that raised the exception. It's important to note, though, these variable name suggestions will only happen in scenarios where the PyErrorDisplay function is called to show the error, and so these won't happen in some REPLs, such as IPython. We're sadly almost coming to the end of our high-level tour of new features, and there's just one more for us to discuss before we part. PEP 626 introduces precise line numbers for debugging, profiling, and tracing tools. Tracing events with the correct line number are generated for all lines of code that are executed. The line numbers are tracked using an attribute of frame objects named fLineNo, which presumably stands for file line number. Like every good video in a series about coding, I'm going to leave you on a massive cliffhanger. If you think what you've heard so far sounds cool, well, I hate to break it to you, the two best new features are yet to come. I'll be talking through the addition of pattern matching and the ins and outs of type hinting in the next two videos, and I'm really excited to share these with you. See you there! Python has always been a very divisive language when it comes to types, being a dynamically typed language by design. This means that the type of a variable may change over the course of its lifetime. However, there are some schools of thought that say even a dynamically typed language should have the option to give type hints to the interpreter. This is for two reasons: to tell the developer and the Python runtime what types are expected within classes and functions, and to keep the program correct. Essentially, it ensures that type checking happens at runtime to enhance the explicit correctness of the program. This video covers some major changes affecting PEP 484, which was the very first PEP to introduce type annotations way back in Python 3.5. Since then, there have been a lot of suggestions around how the type system can be improved, and they all seem to have landed in this version of Python. For those not familiar with type annotations, let me give you a bit of an example. Within the world of type annotations, there are three main ways of using them. The first is within function parameters. These tell the Python runtime what types are acceptable when calling a function. You can see an example on the screen of a function that is being called with a parameter of type string and a parameter of type integer. In general, annotations for parameters take the form of optional expressions that follow the parameter's name. The second way of using these is within function return types, which are represented using the arrow operator after a function's parameter list. And the third is variable assignment, to tell a Python runtime what type a variable is expected to be. It's possible to use the types defined in the typing module for this, but it's not recommended as per PEP 585, which introduces generics and standard types, as you can see on the screen with the type definition of B. Within the original PEP 484, a type was introduced within the typing module called union, which essentially allowed a type, or another type, to be represented as a parameter or a return type. Python 3.10 introduces a way to write this in a cleaner, less syntax-heavy way that most set theorists and TypeScript developers will appreciate. The next exhibit in our tour of new functionality is type aliases. PEP 484 first introduced the concept of type aliases, which mean that you, the user, could define types and then annotate functions and variables with these types. The problem was, type checkers would find it difficult to distinguish type aliases from ordinary assignments, as they didn't look much different. Python 3.10 introduces the type alias annotation, which allows a developer to explicitly annotate their user-defined types to be used for annotation. This is a far more readable way of achieving type annotation, as you can see on the screen. Moving swiftly on to the next exhibit in our tour of typing. In this section of the video, we're going to be talking about type guarding. Python 3.10 has introduced user-defined type guards, adding an annotation to the typing module. This will vastly improve the efficiency of static type checkers during type narrowing. That's all well and good, but what does any of that even mean? A type guard is a conditional expression that alters the flow of a program based on the type of variable detected. Static type checkers use a technique called type narrowing to achieve this, which basically means saying, is this variable a certain type? If so, do this thing. If not, do another thing. You've probably used this many times when checking for null values such as none. If this variable is none, pass over the statement. Else, process the variable. Simple. Python 3.10 is formalizing the type guard as an annotation to make this clearer to everyone involved. There are cases where type narrowing cannot be applied based on static information only, and this has led to issues. Being able to annotate functions as a type guard ensures that everything is nice and explicit. In this example, the function's return type would not simply be Boolean anymore, but typeguard list string. This tells us that a return value of true means the input to the function was indeed of type list string. I could talk forever about types, but I'll not keep you much longer. The final feature that Python 3.10 has introduced regarding types is parameter specification variables. Again, this is very opaque terminology that doesn't mean much by itself. Basically, this new feature is to do with the typing module. It aims to improve the information provided to static type checkers specifically for the callable type. Parameter specification variables are used to forward parameter types of one callable to another callable, essentially ensuring that nothing unexpected happens during parameter passing and allowing more accurate representations of higher order functions. In the example on screen, you can see parameter specification variables being used to create a decorator, which will add logging to a function. The add logging function takes a function as a parameter, passing this function's arguments in using paramspec variable p. Previously, there was no nice way to do this without using the much-hated anyType from the typing module, which meant that a type checker can't check the inner function at all. The use of the anyType is actually considered to be a code smell on many dev teams, so this addition will be quite a relief for them. That's all from me for this video. Why don't you have a go at using the new features yourself? I promise it's great fun. Just my type of fun. Let's take a deeper dive into the topic we've all been waiting for with bated breath. That's right, I'm going to be sharing insights about the new pattern matching feature of Python 3.10. Any of you who have been programming in Java or C or OCaml or Scala or, well, any other language will be very pleased at this addition, I'm sure. The basic premise of pattern matching, for those who aren't aware, is that a data object is matched to a literal from several options. Take a look at the example on screen for a clearer idea of what this means. A variable named status is passed into a function, and that variable is compared against several cases. If it matches one of these cases, something happens, depending on what has been matched. There's usually a base or default case, which is what happens if none of the other cases match. In this case, a string stating something's wrong with the internet is returned. In Python 3.10, the underscore acts as a wildcard to catch all other cases, ensuring the subject will always match. That last example showed us what the new pattern matching in Python looks like at a very basic level, and for most cases that will be enough. However, I'm going to show you some other cool things we can do with pattern matching. For a start, you can add some syntactic sugar and combine several literals using the vertical slash symbol. This acts just like it does within the new union type, as mentioned in the previous video. But what happens if we begin to have even more fun with this, and try to break it? What happens if we leave out the base case and submit something that will never match? Well, as it turns out, this is a no-op. Nothing will happen if you try to do this. But on the flip side, no errors will be thrown, so this may lead to some strange buggy behavior. So make sure to add your default base cases. Previous PEPs have specified that type checkers such as MyPy need to be able to handle exhaustiveness checking, and so I'd recommend always using a static type checker when coding. So far, we've only seen pattern matching where literals have been used. What about if we want to include variables in pattern matching? How does that work? In this case, the variables x and y can be set to anything, to create a point pair. Personally, I would check that their type is numeric before launching into this pattern matching, just as a sanity check. But this example demonstrates cleanly how to use variables in combination with literals with pattern matching. There are some more contrived ways of using pattern matching too. For example, you can match the class name followed by an argument list resembling a constructor. One feature I think is a little magical is the match_args built-in class, which essentially binds variables to preset values. Basically, it means you don't have to repeat yourself as much. Patterns can be nested, like in this example, and the wildcard or base case can also be used in more complex patterns. The only limit in this new feature is your own imagination, it seems. And this is arguably both a blessing and a curse. You can also add if statements to pattern matching, which increases the flexibility and complexity of the feature. Similar to the previous video, this is known as a guard pattern. If the guard is false, match goes on to try the next case block. I think this will be very useful for any game developers who are setting out to make adventures with Python 3.10. I'm thinking of having a go myself. There are many more aspects of pattern matching to cover, such as sequence patterns supporting wildcards and unpacking assignments, mapping patterns supporting capturing values from a dictionary. Subpatterns can be captured using the as keyword, and named constants from enums may be used in patterns, but you have to remember to use dotted names to avoid being interpreted as a capture variable. That's all from me on pattern matching, but there's still lots to discover. The full specification, motivation, and rationale behind this huge new feature are detailed in PEP 634 and 635, and you can find a longer tutorial in PEP 636. Let's talk about the big improvements to modules in Python 3.10. I would usually discuss new modules before I dive into improved ones, but it seems like there are no new modules this time around. All the Python core contributors have been focusing on making things better this development cycle. I'll go through the bigger changes here in alphabetical order, whereas the next video will cover the smaller but still useful changes. The first improvement I'm going to cover is within the curses module. Now, when I first encountered this module, I thought it must be something to do with magic, and in a way, it is. This library deals with writing GUI-like, text-based programs that run in nearly every terminal emulator. Python 3.10 transparently adds the extended color functionality that's available in ncurses 6.1, and you can see the available functions here on screen. Next, we'll be talking a little about data classes. I only discovered the concept of data classes within the past year, and now I wonder how I ever did without them. They were introduced in Python 3.7 and are just regular classes, except they're made for storing state rather than logic, and do a lot of boilerplate code for you. They can be thought of as mutable named tuple classes too, if that helps to conceptualize them, and you can read more about them in PEP 557. So what's new in the data class module then? Well, frankly, there's a lot to be excited about. Firstly, the concept of slots has been added, which was already present within regular classes. The special attribute slots allows you to explicitly state which instance attributes you expect your objects to have. This means that value references don't need to be stored in the dict of a class, which can lead to provably faster attribute access. Another data class-related module improvement is the addition of keyword-only fields to data classes. There are a few ways of specifying this. As in the example on screen, you can state that every field will be keyword-only. You can also specify keyword-only on a per-field basis. If you set keyword-only on individual fields, be aware there are rules about reordering fields due to keyword-only fields needing to follow regular fields. You can also specify that all fields following a keyword-only marker are keyword-only. Another awesome and unrelated addition to data classes is that the pretty print module can now print data classes as of this release. That was a lot of talk about data classes, but now I'm moving on to chat about the distutils module. This module is deprecated completely, and has now been fully replaced by the third-party packages, setup tools, and packaging. This is arguably an improvement, as it's one step closer to standardizing package distribution in Python. We'll get there. The hashlib module has many improvements which bring it in line with industry standards. For a start, it now requires OpenSSL 1.1.1 or newer, and it also has preliminary support for OpenSSL 3. The pure Python fallback of the password-based key derivation function, which uses HMAC as a pseudo-random function, has been deprecated. In the future, this will only be available when Python has been built with OpenSSL support. Continuing with the theme of security, the SSL module also requires OpenSSL 1.1.1 or newer, and has preliminary support for OpenSSL 3. This module as a whole now has more secure default settings. Ciphers without forward secrecy or SHA-1 MAC are disabled by default, and SSL context defaults to minimum protocol version TLS 1.2. There's also a new timeout parameter in the SSL get server certificate function, And a new verify flag has been added which instructs OpenSSL to accept intermediate certificate authorities to be treated in the same way as self-signed root CA. Now that the security portion of the video is over, I can assure you this video is nearly at an end. I just have one more major improvement to report on, and that is, yes, you've guessed it, the typing module. As well as the major changes with type hinting, there were also a number of smaller changes introduced that are still quite important. First up is the behavior of typing.literal, which was changed to conform with PEP 586 and to match the behavior of static type checkers. Literal now dedupes parameters, and equality comparisons between literal objects are now order independent. Another surprising and reassuring change is that literal comparisons now respect types. Previously, the example on the screen evaluated to true, and it's now false. Thank goodness. Literal objects will now raise a type error during equality comparisons if any of their parameters are not hashable. However, declaring literal with unhashable parameters will not throw an error, so be careful. That's all from me for the big module improvements for Python 3.10. Welcome to the second installment of our discussion on improved modules. This time we'll be discussing the smaller improvements to modules in Python 3.10. The full list can be found at this URL. This will be a quick video with just the highlights, so buckle up. So first up, the async.io module has added a new function to its abstract event loop class. Continuing within the world of async programming, the context.lib module has added a context manager to safely close async generators and async resource objects. An async context decorator class has also been added to support usage of async context managers as decorators. The index method of array.array now has optional start and stop parameters, much like the list.index function. This function returns the index of the first occurrence of a specified item in the array. The optional arguments start and stop allow this functionality to be applied to subsequences of an array. Also, to support base 32 encoding with the extended hex alphabet, the base64 module has added 2 extra functions. In other encoding news, the normalize encoding function of the encodings module now ignores non-ASCII characters. Turning to file system traversal now with the glob module, parameters rootdir and dirfd have been added to the glob and iglob classes. These allow the user to specify the root directory for searching. The idle Python shell and its related idle.lib have had some updates to reflect the new features in Python 3.10. It's also settling a long-running heated debate amongst Pythonistas by using spaces instead of tabs by default for interactive code. A shell sidebar has also been added to improve developer experience. Exciting times! On to operating system libraries now. Within the OS module, there have been some constants added for interaction with macOS. A splice function has also been added to the OS module, which enables data to be moved between 2 file descriptors, as long as one of these is a pipe. Additionally, os.path.realpath now accepts a strict keyword-only argument. When set to true, an OS error is raised if a path doesn't exist or a symlink loop is encountered. Pathlib has also had a lot of additions, with slices and negative index support being added to purepath.parent. The stat and chmod functions of pathlib.path now also accept a follow symlinks keyword arg to keep consistent with changes in the OS module. On to the statistics module now. Excitingly, functions for covariance, Pearson's correlation, and simple linear regression have been added. Biologists and machine learning engineers will be pleased, I'm sure. Within the sys module, an attribute named sys.org.argv has been added, which returns a list of original command line arguments passed to the Python executable. Another attribute called sddlib module names has also been added, which contains a list of all standard library module names. That's handy. Threading.getTrace and threading.getProfile have been added as the opposing functions to threading.setTrace and threading.setProfile. We've all had errors at some stage of our development careers. Now when you have your next exception, you'll be glad to know that the traceback module functions for formatting and printing can now take an exception object as a positional-only arg, so you can make your stack traces readable. And finally, some security concerns have been patched within URL.lib. Earlier Python versions allowed using both semicolons and ampersands as query parameter separators. Due to security concerns, this has been changed to allow only a single separator key, with ampersand as the default. Hope you're still with me on this whirlwind tour of the smaller improvements included within Python 3.10. This may be the end of the modules I'll be talking about, but you can find more information about all the improvements at the What's New page for Python 3.10, shown on screen. See you in the next video! Python 3.10 has an amazing amount of module improvements. But what about module removals and deprecations? We'll start off by talking about the language features that have been deprecated. Deprecation means marking features for removal and replacement, and discouraging their use. So what's been deprecated this release of Python? Starting in this release, there will be noticeable efforts to begin cleaning up old semantics that were kept around for Python 2.7 support. This will include the find loader and find module functions of importlib. Currently, Python accepts numeric literals immediately followed by keywords. This allows confusing and ambiguous expressions like what's on screen right now. Starting in this release, a deprecation warning will be raised if a numeric literal is followed by one of these keywords. As I've mentioned before, the entire distutils namespace is deprecated, to be removed in Python 3.12. Predictably, I'm going to talk about the typing module again. It's the star of the show in this release. From 3.10, importing from the typing.io and typing.re submodules will raise a deprecation warning. Anything belonging to these submodules should be imported directly from typing instead. pathlib.path.link2 is deprecated, and slated for removal in Python 3.12. Use pathlib.path.hardlink2 instead. The following threading methods are now deprecated. And there's more. It seems that unnecessary getters and setters have simply been replaced by single properties. On to async code. Asyncio.getEventLoop now emits a deprecation warning if there's no running event loop. In the future, it will be an alias of getRunningLoop. Asyncio functions which implicitly create a future or task object now emit a deprecation warning if there's no running event loop and no explicit loop argument is passed. The Python thread debug environment variable is deprecated in Python 3.10 and will be removed in Python 3.12, as it produced way too much logging. It can be accessed within a debug build of Python, but the general consensus is that there are many more effective thread tracing tools. There are many more deprecated modules and features, but these are definitely the highlights. We'll move on to removed modules now. There aren't many, and most of the removals are from private and undocumented bits of modules. The parser module has been removed, which was deprecated in 3.9 due to the switch to the new PEP parser. The public API functions on screen associated with the parser module have also been removed. From Python 3.9, collections abstract base classes have been moved to the collections.abc module. This module has also been removed, as it was unnecessary because the warnings module has been converted to a built-in. The loop parameter has been removed from most of async.io's high-level API following deprecation in Python 3.8. The motivation behind this change is multifold. Firstly, it simplifies the high-level API, as these functions have been implicitly getting the current thread's event loop since Python 3.7. There isn't a need to pass the event loop to the API in most normal use cases. Event loop passing is error-prone, especially when dealing with loops running in different threads. Note that the low-level API will still accept the loop parameter, if you really need it. So that's it then. There wasn't as much to talk about with regards to removals and deprecations as there was to improved modules, but I see that as a positive thing. Join me in the next video for details on how to port to Python 3.10 from earlier versions. See you next video! Porting to Python 3.10 is a lot simpler than porting to Python 3.9, because support for Python 2 is no longer a consideration. Python 2 reached the end of its life as of January 1st, 2020, and no new bug reports, fixes, support, or changes will be made to it. If you haven't upgraded already, I would strongly advise you to do so. I've covered some ways of upgrading from Python 2 to 3 in my last course, First Look Python 3.9. So as a result of that, there's not too much to talk about that isn't a major research expedition into the Python C API. That's probably outside the scope of this first look course, but I'll let you in on a few secrets that I think are important when upgrading from earlier versions of Python 3. You can find details of changes to the underlying C API at the link on the screen if you'd like. So if I want to upgrade from Python 3.9 to Python 3.10, what do I need to do? I'll go through the steps if you're working on a Mac, on Linux, and on Windows. On a Mac, there are several ways of installing Python. One relatively easy way of installing Python is through the Python website itself. From here, you can install the most recent version of Python 3. This is a universal binary build of Python which runs natively on the Mac CPUs. What you get after installing is a number of things. A Python 3.10 folder in your Applications folder, where you find idle and Python launcher, and the Python framework itself, which is stored within your library directory. To uninstall MacPython, you can simply remove these three things. Another common way of downloading Python 3.10 is through the Mac's third-party package manager, Homebrew. You can install Homebrew at the following link on the screen. And you can check the system version of Python with the second command. And you can check if you already have Python 3 installed using the third command on the screen. macOS since version 10.8 comes installed with a system version of Python, which is usually Python 2.7. This doesn't need to be changed, and may cause issues if it is changed. Luckily, Python 2.7 and 3 can coexist on Macs, and if you have Homebrew installed, it's as simple as running the following commands. To downgrade again, simply do the same thing for another version of Python. Homebrew may complain about architectures if you're on the new Apple M1 chip, but just follow the guidance that it gives you. On to Linux now. General guidelines for updating and maintaining the latest version of Python on many distros can be found at this link. I'm just going to walk through installation on Ubuntu in this video, as the process is fairly similar for most of the popular distros. There are two main ways of getting the latest and greatest Python version: installing Python 3.10 from the dedsnakes PPA, or cloning the GitHub repo. You can also build it yourself from source, but that's outside the scope of this video. So the first step is to make sure your system is updated and has the required packages. You then need to install the required dependency for adding custom personal package archives. Then, once that's completed, add the dedsnakes PPA to the apt package manager sources and install Python 3.10. You can verify that the installation has worked by running the version command. Another way of installing Python 3.10 that isn't building it from source is to clone the dedsnakes repository from GitHub, and follow these instructions from the root directory of the repo. Dedsnakes allows you to install multiple versions of Python on your Ubuntu machine. The repo also has a ton of great resources if you want to learn more about Python or CPython development. This will work on Unix systems, Linux, BSD, macOS, and Cygwin, so it's really flexible. We'll continue on to our final OS, which is, of course, Windows. Simply navigate to the official Python website and download the Windows installer for your system architecture. It's really important to note that Python 3.10 can't be used on Windows 7 or earlier, so you'll have to have Windows 8 or above in order to upgrade to Python 3.10. As an extra treat, for those of you who simply want to play with the new features, with none of the OS installation hassle, there's always good old Docker. Docker containers are operating system independent, lightweight, standalone, executable packages of software that can be spun up on your machine super easily. Head over to the Docker website and download it. Make sure that the Docker daemon is running before doing anything else. You can start the Python 3.10 container and drop right into a top-level session by running the following command: magic. And that's all there is to it. Thanks for upgrading to Python 3.10 with me. During this course, I've made use of lots of resources and links that could be really useful for you to look at. Thanks for joining me on this tour of Python 3.10. Here are some links that I think will help get you up to speed with what's new, and will hopefully be fun to read. I've also found that there are lots of communities online for Python development, all full of super knowledgeable people who are always willing to lend a hand. Check out some of these communities if you want to talk to fellow Pythonistas. There's a Discord, an IRC channel, a Slack channel, and a weekly email newsletter, so you can get as involved as you want. I hope you found this course useful. Let me know if it helped you. Thanks again for joining me, and I hope you have some fun times with Python 3.10.